Welcome to day 17 of our data science journey. Today we dive into Matplotlib, a crucial Python library for data visualization. We'll explore how it transforms raw data into insightful visual stories, making complex information accessible and engaging. Matplotlib is incredibly versatile. Whether you want to create simple plots or more complex graphs, it allows you to craft visualizations that make your data speak. We'll start by looking at line plots, bar plots, and scatter plots, three essential tools in any data scientist's toolkit. Let's begin with line plots. A line plot is ideal for visualizing trends over time. Think about tracking stock prices, temperatures, or sales data over days, months, or years. Let's see a simple example where we're using a combination of styling commands to control the aesthetics of both the figure and the plot itself, adjusting colors to create a clear and visually appealing output. You can experiment with different colors, line styles, and markers to suit your particular needs and make your visualization stand out. In this plot, each day is connected by a line, allowing us to visualize how temperatures change over time. Let's break down the parameters used in this Matplotlib script so you can get a deeper understanding of how they work and how you can customize your visualizations further. Marked commands set the background colors of the plot. There are different ways to set the colors: hexadecimal color code, color name, or just a letter. Next, marker O defines the style of the marker at each data point. Color sky blue specifies the color of the line connecting the points. Line style dashed, this sets the style of the line. In this case, a dashed line is used instead of the default solid line. We can add a title, daily temperatures, to our plot and set a color. You can choose any color for the title using either named colors, hex codes, or just the letter W. It is a good practice to name the axes, so do not forget to use X label and Y label parameters each time. Make sure that the labels are clearly visible on the backgrounds you use. The grid function enables or disables grid lines on the plot. When true, grid lines appear on the plot, making it easier to align data points with the axes. The tick parameter customizes the appearance of the ticks on both axes. Colors white changes the color of the tick labels, the numbers along the X and Y axes, to white, ensuring they're readable against the dark background. Finally, plot show renders and displays the plot. This function is crucial because it ensures that the plot is visible when running the code. Next, let's talk about bar plots. These are perfect when you want to compare categories, like sales in different regions or population by country. For instance, imagine we are analyzing the performance of various product lines. For this plot, we are using various styling commands to customize both the figure and the bars. The labels are positioned halfway up the bars to highlight values directly on the data. The text color and font weight are adjusted for clarity and emphasis. Let's see how to achieve such plot. With bar plots, the height of each bar represents the value for that category, making it easy to compare data visually. You can also customize the bars by changing their colors or adding labels to make the plot more readable. Plot bar creates the bar plot, and the bars variable stores information about each bar in the plot. Color command specifies the fill color of the bars. If you want to place the values in the middle of each bar, you need to use the plot text function to add text annotations. Specifically, you'll want to position the text horizontally at the center of each bar and vertically at the halfway point. This involves calculating the center of the bar for the horizontal position and using half the height of the bar for the vertical position. By setting the alignment to center for both axes, the text will be perfectly centered on the bar. Do not forget to set title and name the axes. Use plot show to render the plot. Finally, we have scatter plots, which are great for exploring relationships between two continuous variables. For instance, you might want to examine how marketing spend impacts sales. Scatter plots allow you to spot correlations or patterns in the data. To define a scatter plot, we need the plot scatter function to visualize the relationship between marketing spend and sales. Here we set the color of the points to coral, which stands out nicely against the background. We also adjust the transparency with alpha 0.6, so the points are semi-transparent and don't completely obscure each other. Adding edge colors B gives each point a blue outline, making them more distinct. The size of each point is set to 100 for better visibility. To highlight the underlying trend, we fit a linear trend line to our data. This is done with NumPy polyfit, which performs a straight line to the marketing spend and sales data. We store the slope and intercept of this line in variables m and b. Using plot, we then draw this trend line on our scatter plot. The line is colored blue and dashed to differentiate it from the scatter points. This visual aid helps us see the overall trend in how sales increase with marketing spend. Matplotlib provides a wide range of plotting options, from simple line plots to more detailed bar and scatter plots, each serving different purposes depending on the data at hand. You can start with these foundational plots to get comfortable with visualizing your data, and from there, you can dive into more advanced features like styling and customization. Next time, we'll shift gears and explore Seaborn, a powerful library built on top of Matplotlib, which specializes in creating beautiful and informative statistical plots with ease. Stay tuned to continue mastering the art of data visualization.